Welcome back. That was a quick break there. So I imagine there might be a couple people straggling in here, but in interest of time and to keep us on schedule, we're going to go ahead and get started. Again, my name is Dan Stark. I'm a Forestry and Natural Resources Extension Agent, and I'll be your moderator for this next section. Starting off with, we're going to get started with Tim Bryant from the U.S. Forest Service. Tim is the Oregon coordinator for the U.S. Forest Service Aerial Detection Survey Program, which is a collaborative between the Forest Service and Oregon Department of Forestry. We've heard a little bit about your work already, Tim, and the good stuff you do for our forest. So please take it away.
All right. Thanks, Dan. Let me share my screen here. Well, thanks everybody for tuning in, and thanks for the chance to be here to give a summary of the Aerial Detection Survey Program in Oregon. Like Dan said, my name's Tim Bryant, and I work for the U.S. Forest Service. So almost every state in the United States has some form of forest health focused aerial detection survey program. In Oregon, this is a collaboration between Oregon Department of Forestry and the U.S. Forest Service. And in fact, a lot of the people that are presenting today and tomorrow contribute a lot of time and resources to making that aerial survey happen every year in Oregon. So what we do is we document forest health across the state. So primarily that's where the damage occurs, what's causing the damage, and the damage severity level. We provide these results to land managers, academia, anybody really that's interested in using the data. There's nothing confidential or internal in nature about this data. We do our best to make it freely available, and we provide our time to support people who are interested in using it. One thing that's really awesome about the Aerial Detection Survey Program in the Pacific Northwest is that it started continuously in 1947, and it's been carried out annually since then. So that makes this data set awesome for looking at what's happening in your area of interest from year to year, and then also putting that into perspective. So if you notice something this year, you can look back and say, in the scale of time from 1947 to the current, is this actually unusual and worth looking into further? A lot's changed with the aerial survey methodology since 1947. With the advent of GPS technology, the spatial accuracy of our mapping has gotten a lot better. And with GIS and spatial analyses, the way that we deliver and analyze the data has also improved by leaps and bounds. But in a lot of ways, it's really similar. We still sit in the airplane and look out the window and map what we see. So in Oregon and Washington, the Pacific Northwest Aerial Detection Survey Program is responsible for surveying 67 million acres of land annually. We survey forested lands in all ownerships. In Oregon in 2023, we surveyed 37 million acres. We do our best to survey the whole state every year. And oftentimes we are not able to accomplish a 100% survey, but we usually get very close. The biggest exception to our 100% survey efforts was in 2020 with the pandemic. We had to scale back the survey significantly for safety reasons. In 2023, the exceptions to the survey in Oregon were all for fires. So there was the Lookout Fire, the Double Creek Fire in Northeast Oregon, and then in the 2022 Cedar Creek Fire. So after a fire burns through an area, we give that area about 2 years off until we survey it again to make sure that when we do go back and start mapping in that area, we're actually mapping insect and disease signatures instead of delayed fire mortality that's being directly caused by fire. So we monitor such a large area using a variety of tools. Our bread and butter is really fixed wing aircraft. And the one in the top left is a Kodiak 100, and it's probably the airplane that gets the most flight time for forest health in this region, but there are others that we also use. More and more, we're relying on satellite data to complement the fixed wing aircraft. And this is everything from change detections, so seeing what's different between two time periods, and that helps us hone in on areas that we need to pay more attention to, And it also helps us map the full extent of really large events, such as the fur engraver outbreak that's been going on in Central Oregon. We spend a lot of time on the grounds. We ground check a certain percentage of our work. And especially if we have a question about what we're seeing from the air, we always go and look at that on the ground. And so ground checking is a really important part of the aerial detection survey. And more we're using UAS data to kind of capture photo and video perspective from above the canopy to help tell the story about what we're seeing, and then also capturing multispectral imagery and starting to carry out forest health analyses that way as well. So just to give an example of what we're doing when we're surveying, the plane flies over an area and we draw polygons and points over clusters of current year mortality. So that's the orange trees. And so larger pockets of mortality get a polygon around them, and smaller pockets get a point. So if it's 1 tree up to 15 trees, we'll put a point over it. Polygons are attributed with a host and a damage causal agent. In this case, the host looks like grand fir, and the damage causal agent might be fur engraver. And then we also attribute the polygons with a severity in terms of the percentage of treed area affected within that polygon. So in this example, all of these would be pretty high severity polygons because greater than 50% of the treed area is affected. The points also get a severity call, but their severity is in terms of the number of trees affected under that point. And then they get the same host and damage causal agent attributes as well. So that information is transferred to a tablet that we're holding in our hands while we are flying. And we use an electronic pen to write on the tablet screen. On the right here is what we call quick keys. And these are pre-coded combinations of damage agents and hosts so that we're not having to look those up while we fly. And then on the left is showing a zoomed out map of Oregon. And the blue are areas that at the point where this screenshot was taken, the blue are areas that we have yet to survey, but this is just showing the survey lines that we fly every year across the state. And then the pink at this point is areas that we had already surveyed. So what do we monitor for? We essentially monitor for all types of forest damage that we can see from an airplane. And so examples of this are mortality, defoliation, top kill, diebacks, and declines. And that's in the biotic category. In the abiotic category, examples of things that we monitor for are mudslides, avalanche, wind, heat, and droughts. And we'll go back and just point out that on the left here is some ponderosa pine mortality, likely related to bark beetles. And then on the right is Douglas fir tussock moth and Douglas fir. And then this photo is taken in Western Oregon showing damage caused to Douglas fir by heat scorch from the 2021 heat dome event. And that event is actually a great example of a collaboration between remote sensing and satellite imagery and aerial detection survey to fully map the extent of a very large event. So the next thing I'm going to do is move to a summary of 2023 findings and recent trends mapped by aerial detection survey across the state of Oregon. I'm going to summarize it in these four zones of Oregon that I'm showing right here. So Northwest Oregon, Southwest Oregon, Central and Eastern Oregon. And these are really just the top headlines from these areas. There's much more data to look at. First thing, let me get my laser pointer here. First thing I want to do is point out some features of these figures that I'm going to be showing a lot of, because there's a lot of information here. There's two y-axes. The y-axis on the left is showing acres affected by the damage causal agent that's in the title. And then the y-axis on the right is the acres flown. So this is indicated by the black dots and the dashed line. And the point of this is just to say, like I was saying earlier, we don't unfortunately get to fly 100% of the state every year. In some years, like in 2020, there are major exceptions. And so I want to be transparent about that and let y'all factor in the amount of area that we actually flown to the fluctuations in the acres affected. The y-axes are not the same on every one of these figures. So if you're comparing figures, look at the actual number of acres affected instead of looking at the size of the bar. So that said, Douglas fir beetle increased in northwestern Oregon in 2023. And where we really saw that increase was within the perimeters of the 2020 Labor Day fires in northwestern Oregon. So in that area, I'm talking about the Beachy Creek fire, the Riverside fire, the Holiday Farm fire, and the Lion's Head fire specifically. We started mapping those areas again in 2022, but the Douglas fir mortality has continued to increase in 2023. So this figure on the right is showing young conifer mortality. And young conifer mortality, for anybody that's been watching ADS data for a while, young conifer mortality is the new word for bear damage. And what we found through ground surveys and research was that bear damage is what we used to call bear damage is actually a complex of bear and root diseases that are affecting young conifers. And so we're moving to this more generalized term. But young conifer mortality increased in Western Oregon and Northwestern Oregon in 2023. And this is really distributed across the area pretty evenly, but if there is a hot spot, it would be in the far northwestern part of the state, closer to Astoria. Western pine beetle decreased slightly, and this is primarily on the east side of Mount Hood, where we see this happening in northwestern Oregon, and fir engraver mortality attributed to fir engraver also decreased. Here's a picture of what a pocket of Douglas fir beetle mortality looks like from the air. And this is on the Mount Hood National Forest near the Columbia River Gorge. Okay, so moving down to southwestern Oregon, we saw a decrease in acres of mortality attributed to flat-headed fir borer. This decrease relative to 2022 was, significant, but it remains elevated far above the level that we had mapped prior to 2022. So this remains, a significant event that's happening in southwestern Oregon. Young conifer, let me see. Got this little, there we go. Fir engraver decreased in southwest Oregon, and western pine beetle also decreased in southwestern Oregon. Douglas fir beetle saw a big increase in southwestern Oregon. And story here is very similar to northwest Oregon. And that is that the majority of this increase is inside of fire perimeters from 2020 and 2021. So that's the Archie Creek fire, and then all of the events that are involved in the Rough Patch complex from 2021, which includes the Jack fire. This was our first year mapping the Rough Patch complex after that fire happened. Here's a picture of Douglas fir mortality attributed to flat-headed fir borer from the air on a hillside near Ashland, Oregon, taken in 2023. Moving over to Central Oregon, fir engraver mortality attributed to fir engraver increased this year slightly over 2022, and this has probably been the forest health headline in Oregon for the past couple of years. Has been this fir engraver outbreak in Central and Eastern Oregon, and this continues to be an event that's causing a lot of mortality in those areas. Acres with western pine beetle mortality also increased in Central Oregon, and this is maybe one of the new highlights for this area for 2023. Mountain pine beetle also increased in Central Oregon, and the area that we saw this was really on the southern part of the Deschutes National Forest and the western end of the Fremont-Wainema National Forest. And then Douglas fir beetle also increased in Central Oregon, and this was especially focused on the northern part of the Deschutes National Forest and the southern Warm Springs Reservation. Here's a picture of some ponderosa pine mortality that we attributed to western pine beetle on the Warm Springs Reservation. And then on into Eastern Oregon, fir engraver mortality decreased slightly. Let's see. Got a little drop down that's blocking my view here. I think that this is western pine beetle here on the right, increased in 2023. Mountain pine beetle in the bottom left increased in 2023, and this is an ongoing outbreak that is focused on the southern part of the Umatilla National Forest and the southwestern portion of the Whitman National Forest, close to where those come together with the Malheur, west of Sumter Valley, and on the north and south sides of the North Fork John Day Wilderness area. There's a number of valleys that have a lot of lodgepole pine mortality that we're attributing to mountain pine beetle. And I've got a picture of that coming up. And then Douglas fir beetle also increased in Eastern Oregon. And this is really focused on the area of the Umatilla National Forest, north and south of the state line, and then into the Wallowa Mountains as well. Here's a picture of that lodgepole pine mortality attributed to mountain pine beetle on the Umatilla National Forest. Large areas that look like this. You can see current year mortality as well as previous year mortality in the brown trees. So I hope by now I've worked y'all into a frenzy and you're so excited to get your hands on this aerial detection survey data and start looking at what's going on in your backyard and your areas of interest. And so in my biased opinion, we've got a great website that is a good place to get started with that type of work. I've got the link here, so I hope this presentation can get shared out and this link will be useful. I'll also try to put it in the chat. But on the website, we've got a data viewer down here, and this is a resource to help y'all keep track of where we are across the survey season, what areas we have already surveyed, and what we've found. And so if you went to it right now, you would likely see a blank map because we have not started the 2024 survey yet. But come late spring, late June, early July, data will start showing up on there within a week or so after we have flown that area. So it's an almost real-time look at what's going on in your area of interest. You can also download historic ADS data back to 1947 and work on your own analyses from there using this data download link. We also have quad maps, and these are USGS quads with aerial detection survey mapping overlain on top of them. And so if you use a program like Avenza, for example, that can take a georeference PDF, you can download the PDF here, put it on your tablet, and take it to the field to ground check or take a look at what we saw from the air. We also have information about special surveys that we do, such as the Swiss Needlecast survey, which is led by Oregon Department of Forestry, or the sudden oak death survey that Gabby was talking about. And then there's also just lots of other information like historical photos from the aerial detection survey program, contacts for forest health, and information about our methods. So with that, I'll say thanks again for having me. And there's my contact information. Please reach out if I can be useful in your forest health pursuits involving aerial survey data. And hope I left time for questions.
Yes, Tim, thank you. You left plenty of time and I didn't even have to use my alarm to warn you for the 2-minute warning. So appreciate you
good.
keeping us on track. And great presentation. Yeah, we have a couple of questions here, so hold tight. We are a little bit ahead of the game. If folks want to ask some more questions of Tim, please now's your chance. Type those into the Q&A box, please. The first one is, let me grab up that Q&A box. This is from Carl Maltzon. In your aerial surveys over areas affected by fire, how do you control for browning due to fire instead of pests? Great question, Carl.
Yeah, thanks. So the biggest thing we do is we give that area time to rest. And so we have been using a 2-year rest period. There's a lot of talk about moving to a 3-year rest period to make sure that we're really giving the area plenty of time to get past the delayed fire mortality and really hone in on mapping the insects and disease signatures instead of that delayed fire mortality. Besides that, ground checking is also a great tool, and staying in touch with the forest health professionals that are there on the ground and familiar with that area.
Okay, thank you. The next question comes internally from Dave Shaw. So he's going to, of course, ask you about some Douglas fir questions. So regarding Douglas fir beetle and fires, has Douglas fir beetle jumped out of the perimeter of the fires much, or mostly restricted to within the fire footprint?
Yeah, and we are seeing it within the fire footprint and then around that area. I'd say an example of that is especially apparent in the data this year on the southern end of the Mount Hood National Forest, where you kind of have the Riverside Fire, the Beachy Creek Fire, and then there was the Bull Complex and the Lion's Head there, also lots of fires. And so we're seeing lots of Douglas fir beetle caused mortality within those perimeters, and then also outside of the perimeter. So I think what you're talking about, Dave, was definitely recorded in the data this year, that the increase in mortality that we saw in 2023 certainly extended outside those fire perimeters.
Great, thank you, Tim. And just great. I was about ready to do some filler stories. So thanks, Ava Philippus, for asking your question here. In the Northwest section, we had the biggest ice storm in memory, at least in 40 or more years, that has devastated great numbers of trees. What do you make of that? Are they likely to occur with greater frequency? Is there anything we could do to mitigate such damages going forward? Maybe different kinds of trees?
See, yeah, as far as mitigating damages from ice storms, yeah, I really don't know about that one. I hope that we'll be able to see that damage from the air this year and be able to map the effects of that ice storm. I've heard that climate change starts to appear as kind of a climate weirding type scenario, and so more and more of these unusual climatic events that maybe used to happen every 50 years might happen every 10, 5 every year. So that might be something that we're starting to see more of now and in the future. Great.
We will, I think we have a time for a couple of these last two ones here. We'll wrap it up with these last two. Ashley is asking, and I think this might be getting at this whole, pathogen versus insect mortality issue. Who's the real culprit? At least I'll bring that in. What is the extent of overlap of various pest disease causing mortality in an area?
Yeah, so we map from aerial detection survey everything we can see from the air. The aerial detection survey methodology is not ideal for mapping pathogens like a root disease. There are some that we can map, like for instance, Cytospora, but oftentimes root diseases are given another attribute. Maybe the insect that actually was kind of the final straw in a long period of decline is actually what we map with the aerial detection survey, when really there is an underlying factor of root disease or site conditions that are an extremely important contributor to that mortality. So we're oftentimes mapping the insect when there's an important pathogen contributor that we can't confirm from the air. So that's important, an important caveat to make sure that you're keeping in mind when you're using aerial detection survey data.
Great, thank you for that, Tim. And this one's just a quickie and it has a little bit more to do about the specifics of your team. Darcy is asking, how many people fly at one time? Are there specialists?
Yeah, there's 2 people in the airplane at a time. You know, if there's somebody training, there could be more, but generally there are 2 people that are mapping, and one's mapping out the right side of the airplane and one's mapping out the left side of the airplane, and neither one of those people are flying the airplane. There's a pilot as well that is in there doing the flying.
Okay, well, thank you so much, Tim. Really appreciate it today. And we're going to move on now to our next speaker. Thank you so much.
Yeah, thanks.
Virtual round of applause for Tim.